Alright, so the first thing I need you to do, this is video 1, we're going to calculate. Oh, by the way, if you watched the other video, those were 1,000 different beams. We're going to calculate the areas of 1,000 different square rectangles with all different shapes and sizes all instantly. You can do it very fast in Excel, but once you learn this, you can do it fast in this too. And this takes you so much further than Excel once you develop it further. As I said, we're going to start you nice and easy, learn to calculate some basic rectangles, make your own module, some basic areas with your own modules. So we're going to create basic modules and do some basic commands, and we're going to get more and more advanced very soon. Very fast, but very easily. By the way, check the links in my description below. So what we're going to make, I keep updating it regularly. Here are some tools. Don't be intimidated, it's not as bad as it looks. Here are some engineering tools that I'm going to be showing you how to make in this video. If you want to see them and download the actual modules and not really learn how to make them, but if you just want to use them, you can download from my GitHub, which is here. There'll be a link to that in the description below. Yeah, have some fun. Anyway, let's do this. I'm going to say new notebook Python 3. So I've got created my own blank notebook, and I first need to make my own data. So I'm going to say file, new, blank workbook, or whatever. I'm going to close. Oh, sheesh. No, that's going to be long. We can close tabs. Oh, okay, that's fine. Right, blank workbook. It's called book 1. We'll name it something else because I've got a bunch of book 1s in that folder. Don't save. First thing I need to do is create my own random numbers. So equals rand between. Why does Excel do that? Anyway, 1,10 times 100. So I'm going to assume these are in millimeters, which is why I want them multiplied by 100. I'll drag it across, put it on row 2, name the first one X and the second one Y. So we're just calculating the rectangles. Sorry, a bunch of rectangles. View section. Oops. Go to view. So we just want to know. Sorry. We just want to know that times that. Yeah, this side times this side. So I want to do 1,000. Just go over 1,000. There you go. Random numbers. Now, for those of you that don't want the data to change, just basically right-click, copy, right-click, paste as numbers, and that takes away the formulas. I'm going to hold Control Z because I want to keep those. I want to show you something later when we change data. So how do we do that? Once we've launched Jupyter Notebook, we need to import pandas. Import pandas as PD. I also need to import system, so import SYS. Then I want to use that system module to import an area on my computer. So at the moment, Jupyter Notebook is looking at one particular area in terms of importing things, spreadsheets, whatever, importing anything into here. And that's the default location on your computer that Anaconda has told it to look at, which is fine. That's where you get the default libraries like pandas, but you want to create your own, and you want to put them somewhere on the computer away from this library to keep it separate. So to do that, I need to find a place on my computer. So I've created this location That's mine. Yours will be different. You can put yours on your desktop. I would recommend putting it all in one folder though. Don't just stick it anywhere. I'm going to copy that and right click, paste. Sorry, no, I'm not going to do that. I've copied it, yes, but I need to use the command first. So sys dot path dot append. So you're appending in the list of paths that it looks at. Open quote, control V, close quote. And before we continue, Jupyter requires you to change these slashes. You know what, I'm gonna control F. There is a way of finding all of a certain thing and changing it. Anyway, never mind. I'm going to manually change each of these slashes. They have to be forward slashes. I don't know why it does that, but whatever. There is a way of changing it. Anyway, then I'm going to import my own module, which you're going to create. If you have an IDLE or a compiling tool like this, create a new one. So I've named mine Engineering 2. I'm going to keep this here because recording my screen seems to slow down my typing. Oh, okay. Alright, yeah, see, it's quite slow. But I'm going to explain how to make this and what it does. This is a very basic area calculator. So, I need to create that. Let's say I create a new one just to show you. New, and then save my new module, call it Engineering 3. And just blank it. Save. Make sure you made it first. And now I'm going to import that one. Import engine as ENG. Import Engineering 3 as ENG. You don't need to tell Jupyter that it is a Python file because it will detect that automatically. It's not like spreadsheets that we're going to see in a minute. And press Shift and Enter. Hold Shift and press Enter. That will run this cell. Now we need to import our spreadsheet, which I haven't saved. I'm going to save it. More save options. Browse. In that location. I'm going to call it Rex. Save it. Now I want to. Pandas has a command which allows you to read spreadsheets. So we say PD representing pandas dot read underscore Excel open bracket open quote, and because we've added this path as an area that to look at, we don't need to put that location there. It will automatically look for the spreadsheet. So I'll say rec, so obviously the same name, or rex dot x lsx xlsx, yeah. Oh, sorry, and before I do that, I need to give this a variable. I want to say r equals pd.read, because I want to now manipulate this, and if I just tell it to read it, it will just read it. But if I give assign a variable to that spreadsheet, I can do something. I can do things to it a lot easier. And underneath, I'm going to type print r. There you go. Now it gives me all 1000, all there. If you just want to see the top ones, there's a certain command for that. I will find that one out now. So if I just want to see the header, a certain amount of rows at the top, I can say R, which is the name of it, dot head open close bracket. There you go. And it gives me the first 5 rows starting at 0 going up to 4. I'm going to close that down. Shift and Enter. That will get rid of it. Now I want to create a tool. I mean, just so you know, what we can do is we can just literally multiply those. I can say R bracket area, so the new column is called area, which is why I'm doing this part, equals R bracket X quote, remember to use your quotes, times R bracket Y bracket, whoops, close the quote, bracket, and then print R. There you go, nice little area converter. But I want to make a tool that I'll be able to reuse again. It will probably be just as long to type, but it's important to have tools, and creating this basic tool will give you the skills to create a more complex tool, and we'll go to more advanced levels where typing in Jupyter here will become too long, and even typing in Excel will become too long, and you'll be faster just doing this. So for example, calculating universally distributed loads, etc., etc. So I'm gonna leave this part because that's what we want to create, a column called area, and I'm going to remove the equation I just put, and what I want to do is come in to Spider, and I want to create this. So what you say is class, I'll do it with you, type class rec, press enter. You should remember to put your colon in if it doesn't automatically do it for you. Then I put my def underscore underscore init underscore underscore bracket self bracket, enter, remember your colon. Now this basically initializes the class. So a class takes in a bunch of values or strings or whatever you tell it you want to give to it, and the modules underneath, the modules inside the class, will take those values and do things with them and produce an output. So one class, let's say you want to take 2 lengths, you initialize it to tell it to take 2 lengths, which is what we're doing here. So this initialize module just initializes it to tell it what data comes in. So after self, you put in a comma and type X and then Y. You can use whatever you want. You can put words in there, and they will be variable. Now self.x equals x, self.y equals y. You always need to do this step also to tell it what x and y are, and that's it. That's your initialization done. Now we're going to create the area calculator. So I say def space area. By the way, the reason I named it rec is because this we just need to give it 2 sides of a rectangle, and so we're going to give it 2 sides of a rectangle, and it will use those to calculate a bunch of things that we learned in primary school. So remember to add the self and the colon. Now I want to tell it that a, or self.a, by the way, self is used because this code is going to be applied to a bunch of numbers, and those numbers vary. So this is an instance of 2 values that you want an output for, and this is another instance, and this is another instance. So when you tell Python, when you add the self dot before a variable, it means that this will be used multiple times, maybe in the same code or the same data set or something like that. So self.a equals self.x space time, you don't have to put the spaces, but I like to, it's neater, self.y. Now we need to output that and say return self.a. That's it, we are done. And I will save that now, but I now need to tell this to use that code. So first thing I need to do, I could start up here and hold shift, press shift and enter all these times, but it won't have updated that module. To update it, I say kernel restart and clear output, so the inputs will all stay. And now I need to tell it to use my new tool, so I'll say eng, as we've seen here, we've imported engineering 3 as eng dot rec. So we have launched engineering 3, or we've referred to engineering 3, and when we say rec, we've launched this particular class of that code. And now we need to tell it what values are going in, so you're going to give it your x and your y, which are bracket from R, this data frame R, open bracket, quote, x. You're just giving it the name of the column. If the column is something else, then give it that name. And then we're going to say column, so comma, because as you can see there's a comma separating these two. Forget about self, that just represents this just tells us how to behave. We just need to put in these two in commas because it's expecting those values. R, open bracket, quote mark, y, bracket. Yeah, we're not done though. All we've done is we've gone down to here. Now we need to tell it which of these we want, because I can have multiple ones of these going down, all calculating different things like perimeter and things like that. So I'll say dot area open and close bracket. That means that this applies to this instance, to each instance. Name eng is not defined. Hold on a minute. Okay, so I haven't changed anything. I don't really know why that happened. Oh, sorry. What happened was, I just realized what happened. I didn't run this first cell again. I started here and I pressed shift and I went down and I hadn't reloaded this. So if I show you the kernel restart and clear output, and I start here, press shift and enter, you have problems. If I start up here, you don't have problems. Now remember, these are in millimeters squared. We don't want that, we want it in meters squared. But just so you know, you can run them all. If you don't want to go through each one, you can run everything all at once. And by the way, this is all 1000 different places. So I mean, even if these were areas of concrete ground, land space or something, this would be your area in meters squared. However, we're doing this as beams or whatever. I don't know. I could divide these by 1000, but I'm going to create a millimeter to meter converter later down the line. So for now, just calculating areas, we don't need to worry about units or anything like that. So that's just a basic area calculator. Please stay tuned for the next video where we'll add a perimeter calculator to our rec class. Please do stay tuned for that, and like, share and subscribe.